We live in an empire of stone, but it is not the stone of the mountains carved by time and tide. It is a stone of our own making, a liquid rock that flows into the molds of our ambition. Every sidewalk you tread, every pillar that holds the sky above your head, is a testament to a single grey miracle. This is the concrete empire. 2 millennia ago, on the shores of the Bay of Naples, the Romans stumbled upon something extraordinary. They took pozzolana, the volcanic ash that blanketed the earth around Vesuvius, and mixed it with lime and seawater. The chemical reaction that followed produced a stone harder than anything nature had offered them. They built the Pantheon, an unreinforced concrete dome spanning 43 meters, wider than any dome built for the next 13 centuries. No rebar, no steel, just volcanic ash and the wisdom to use it. The harbors they poured into the Mediterranean still stand, battered by salt water for 2,000 years. They didn't just build structures, they engineered permanence. In 2023, researchers at MIT cracked a mystery that had puzzled engineers for centuries. Why does Roman concrete get stronger with age, while ours crumbles within decades? The answer was hiding in plain sight. Tiny white chunks scattered through the ancient mix, no larger than a grain of rice. Lime clasts. For years, scholars dismissed them as sloppy mixing. They were wrong. The Romans used a technique called hot mixing, blending quicklime directly into the wet concrete at searing temperatures. When cracks inevitably formed, water seeped in and reacted with those lime clasts, creating a calcium-rich solution that recrystallized and sealed the fracture. The concrete healed itself. In laboratory tests, cracked samples repaired themselves completely within 2 weeks. A 2,000-year-old recipe that modern science is only now beginning to understand. Then the secret was lost. For centuries, the recipe for hydraulic cement vanished into the dust of the Dark Ages. Mankind returned to the slow, agonizing labor of cut stone and timber. Cathedrals took generations to build. The empire was dormant, waiting for a spark of industrial genius to wake it. 1824. Joseph Aspdin, a bricklayer from Leeds, files British patent 5022, an improvement in the mode of producing an artificial stone. He had spent years experimenting in his kitchen, burning limestone and clay at temperatures no kiln had attempted. He ground the clinker into a fine powder and named it Portland cement, not because it came from Portland, but because the hardened result resembled the prestigious Portland limestone quarried in Dorset. It was marketing genius dressed as chemistry. But the real breakthrough came from his son, William, who pushed the kiln temperature past 1200 degrees, creating a cement with ferocious binding strength. That single tweak, more heat, is the foundation of every skyscraper, every highway, every dam on Earth. The Aspdins didn't just invent a product. They manufactured the modern world. By the 20th century, concrete found its backbone, steel. Reinforced concrete married compression with tension, allowing structures to bend without breaking, to stretch toward the heavens. The Hoover Dam consumed 3.25 million cubic yards of it. The interstate highway system poured 47,000 miles of it across America. The skyline of Manhattan rose on it. Today, we pour 4.2 billion tons of concrete every year. It is the most consumed substance on Earth, second only to water. More concrete was poured in the first 2 decades of the 21st century than in the entire 20th. We are building faster than any civilization in history. Behind this river of grey stone stands a $420 billion industry. China National Building Material, CNBM, commands the summit, with a production capacity of 530 million tons per year. Anhui Conch follows at 407 million. In Europe, Holcim and Heidelberg Materials compete for dominance. In India, Ultratech. In Africa, Dangote. China alone produces more than half the world's cement, more than the rest of the planet combined. These are not companies. They are geological forces reshaping the crust of the earth at industrial speed. And wherever there is a crane on the horizon, wherever foundations are being dug, their product flows. In the wake of war, concrete became an ideology. Brutalism, béton brut, raw, exposed, unapologetic. Governments poured it into mass housing for millions. Towers rising from London to Moscow to Sao Paulo. To some, it was a democratic utopia. To others, a cold cage. But whether loved or loathed, brutalism proved one thing. Concrete was no longer just a material. It was a statement. But every empire has its price. Cement production is responsible for 8% of global carbon dioxide emissions. If the cement industry were a country, it would be the 3rd largest emitter on Earth, behind only China and the United States. The chemistry is inescapable. To make cement, you heat limestone to over 1400 degrees. The calcium carbonate breaks apart, releasing carbon dioxide as a byproduct. Every ton of cement produces nearly 900 kilograms of CO2. And we produce 4 billion tons of it every year. That is more carbon than the aviation and shipping industries combined. The material that built our hospitals, our schools, our homes, the material we cannot live without, is quietly, relentlessly warming the planet. The empire is fighting back. In laboratories around the world, engineers are reimagining concrete from the molecular level up. In Canada, CarbonCure injects captured CO2 directly into fresh concrete, where it mineralizes and becomes permanently trapped, strengthening the mix while reducing its footprint. At Northwestern University, scientists have created a carbon-negative building material from seawater and electricity that can store over half its weight in CO2, mimicking the way coral builds its skeleton. In the Netherlands, researchers have embedded bacteria into concrete that awaken when water enters a crack, producing limestone that seals the fracture from within. And across Asia and Europe, robotic arms now print entire structures in hours, not weeks. We are moving from the grey slab to the living structure, from carbon source to carbon sink. Long after we are gone, our concrete bones will remain. Geologists already have a name for it: the anthropogenic rock layer, a stratum of man-made stone that will mark our presence in the geological record for millions of years. It is our footprint pressed into the crust of the earth. We are the architects of the concrete empire, and its story is far from finished. Next time, we follow the skeleton inside the stone, the Steel Kings.